7.5, factoring x squared plus bx plus c. So we're going to be factoring trinomials in this format where b and c would just be some numbers. So it might be x squared plus 2x plus 4 or something like that. Okay, so first, factoring polynomials, that means breaking an expression up into factors, and you want to break them up as much as you can. So breaking it up into two or more things that you're multiplying together, okay? And when factoring polynomials, you always want to factor out common factors first, all right? So there are many different ways to factor. I'm going to, and many different methods for factoring polynomials and trinomials. For factoring trinomials, I'm going to use a diamond problem. Okay, and so it's a little puzzle. So here I've got a 7 on top and a 12 on bottom. And if you look, there's a little plus sign above the 7 and a multiplication sign below the 12. So what I'm doing here is I'm going to look for two numbers that will add to 7, and the same two numbers will multiply to 12. Okay, so you could start with the top and think, okay, well, 1 plus 6 is 7, but then 1 times 6 is not 12. You could go through those, but there's actually an infinite amount of pairs that you can add to get 7, because you could have 100 and negative 93, right? So I like to actually start with the bottom. I'm thinking about the different ways that I can multiply to get 12. So I'm just doing a little brainstorming here. 1 times 12. I could do 2 times 6. I could do 3 times 4. I could also do the double negative versions of those. So negative 1 times negative 12, and negative 2 times negative 6, negative 3 times negative 4. Okay, those are all the different ways that I can multiply to get 12 using integers. I'm not using fractions or decimals here. Okay, and then I'm just going to look through these and think, well, do any of them add up to 7? And those two do. Okay, so that means the solution to my diamond problem are the numbers 3 and 4. So I put the numbers 3 and 4 in these two slots. And you could put them in either order. You could put 4, 3 or 3, 4. It doesn't matter. Okay. All right, so let's try it again. I'm not usually going to write every pair, but it's actually the same pairs for this next one, right? So just to save myself from rewriting these, I've got two numbers that multiply to 12. There's all my options, and I'm looking for two that add to 8. And 2 and 6 would add to 8, right? So 2 plus 6 is 8, and 2 times 6 is 12. Okay, multiplying to get 10, thinking about different options. And I could do the double negative, so negative 1 times negative 10, or negative 2 times negative 5. And only one of those adds up to 7. That's the 2 and the 5. Okay. 24, there's a whole lot of pairs. Now, I'm not going to write the double negatives here because I'm adding to get a positive number, right? If you're adding to get a positive number, that means we need two positive numbers we're adding together. I need the double positive version. So I'll just write the double positives. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. I think I got all the pairs there. And then there's the double negatives. There's only ever going to be one pair that works. So as soon as you find one pair that works, you could stop brainstorming, right? 4 plus 6 is 10, and 4 times 6 is 24. So my solution there is 4 and 6, or 6 and 4. Again, you could flip it the other way. Okay. All right, let's start looking at this. So 36, thinking 1 times 36. I could do 2 times 18. I could do 3 times 12. I could do 4 times 9. 5 doesn't go into it, but 6 times 6 you could do. I think that's all of them. And there's only one that adds up to 13. That's 4 and 9. Okay. So I got the same pairs again, but now I'm looking for two that add to 12, and that would be the 6 and the 6, right? Okay. Now, let's get into some negatives. When I'm looking at negative 28, that means one of the numbers I'm multiplying by has to be positive. So this is a pair, okay? But also this is a different pair because it will add up to a different thing, right? So I need one of the two to be negative, and you've got really two pairs for each set of numbers because either one could be positive or negative, okay? And let's see, I could use a 2 and a 14. One of them would have to be positive, one negative. Okay, I still don't see any that are going to add up to -3, so let's keep going. 4 and 7, I could have 4 and -7 or -4 and +7. Okay, and I can get a -3 out of these with this pair. It doesn't work with -4 and +7, but it does work with these, right? 4 plus -7, that's the same as 4 minus 7. So that would give you -3, okay? Looking at these same pairs, if I'm looking for a pair, because it's -28 on bottom again, I'm looking for a pair that adds to +3, and that would be -4 and +7. So again, either order, but here the 4 has to be negative and the 7 has to be positive. Okay, let's try a couple more on the next page. So here we're multiplying to get -7. There's not too many ways we can do that. It'd have to be 1 times -7 or -1 times +7. And I need a pair that adds up to +6. So that's going to be that pair, right? Same two pairs again, multiplying to -7. But I'm going to use the other one now because those add up to -6. Okay? And here, let's see, we got -56. So, I've got this pair, 1 times -56, but also -1 times +56. Well, those won't add to -1, either one of them. So let's keep going. I like to, I could do 2 times something, right? But the first thing I think of when I'm thinking multiplication, when I see 56, is 7 times 8. So let's look at those. And since 7 and 8 are so close to each other, then that means we're going to be able to get a pair that adds up to -1. So 7 and -8 are the winning combo. Those certainly aren't all the ways you can multiply to get -56, but if you think of it before writing all of them down, you don't have to write any of them down. You could think through them in your head, which is actually what we're working towards. Okay. All right, so now let's take those diamond problems and apply them to the situation. So we're going to be factoring trinomials like these in the form x squared plus something times x plus or minus something, right? So what you want to do is take the b, that's the coefficient of the x term, so the number in front of the x. You want to take this number and put it in this slot, okay? And you want to take the c, which is the number at the end, and bring the sign with it. So it's not just a 7, it's a -7. That's going to go down here, okay? And then I'm going to solve this diamond problem just like I did before. Now that happens to be this exact diamond problem, right? So my solution there is going to be -1 and 7 in either order, but the 1 has to be negative, the 7 has to be positive, okay? And the reason I'm doing that is because when I factor this trinomial, it's going to look like this. I'm going to get 2 binomials, and if you think about foiling this together, the first part would be x squared. X times x is x squared, okay? So then I just have to figure out what goes in the back of each of these parentheses. And what goes in the back is the solution of my diamond problem. So I'm going to have a -1 and a +7. And now this is factored, okay? And you could test it out by foiling it together. If you did the multiplication, if you multiply these two together by foiling or by another method, that'll get you back to this trinomial, okay? All right, so let's try another. So again, since this begins with an x squared, as all the problems in this section are going to, I know if it's factorable, it's going to look like that. And I just have to figure out what goes in the back of the parentheses. And that's where the diamond problem comes in. So I'm putting the -6 here. Make sure the negative goes with the 6. That's important. And then -7 goes on bottom. And hey, that looks familiar. It's right up there, right? So the solution to that diamond problem would be 1 and -7. And that's what goes in the back of my parentheses. So I got a +1 and a -7. Okay. All right, let's try another. So here you might think, oh, there's not a number in front of the x, but you could write that as -1x, right? So that means on top I'm going to write -1, on bottom I've got -56, and again that matches up with this. So it's the same diamond problem from right up there. So that would be a 7 and a -8. So I'm going to have x plus 7 and x minus 8. Okay, the diamond problem is just a structure to help you get used to the idea of we're looking for two numbers that multiply to this, and we're looking for those same two numbers to add to this. And that's what goes in the back of your parentheses. So eventually, maybe you can do this without writing a diamond problem at all. But this is good training to get in the habit of what you're looking for, how you're going to find these numbers. Okay, so let's try a few more. So a 9 goes on top here, and the 20 is going to go on bottom. Okay, and then I'm thinking about different pairs here, multiplying to get 20. Let's just start brainstorming. 1 and 20, those don't add up to 9. 2 and 10 do not add up to 9. 3 doesn't go in. 4 and 5, those do add up to 9. Okay, so I found my combo here. And so this is going to factor to x plus 4 times x plus 5. Okay. All right, let's try another here. So 3 goes on top, negative 40 goes on bottom. And I'm multiplying to get negative 40. So, hey, this is not going to work. Can't get a 3 out of that. 2 and 20 is not going to work. So I'm kind of just brainstorming. 3 doesn't go in. 4 and 10, I can't get a 3 out of a 4 and 10. Let's try a 5 and an 8. So 5 and negative 8, or negative 5 and positive 8. So those will work, right? I can get a positive 3 out of those when I add them together. So negative 5 and 8. So this is going to factor to x minus 5 times x plus 8. Okay, all right, one more here. Put a negative 7 here and a negative 18. So let's start going through the combos. Okay, I can't add either of those up to negative 7, so let's try 2 and 9, a 2 and a negative 9, or a negative 2 and a positive 9. And those ones will add up to negative 9. So 2 and negative 9 are the numbers I'm looking for. So x plus 2 and x minus 9. Once again, either order, right? So you could write x minus 9 times x plus 2. That's fine, but the 2 has to be positive and the 9 has to be negative. If the signs are different, that's not going to work. Okay. On the last page, we're going to try a word problem, and this one's going to be a little tricky. So this says a farmer plants a rectangular pumpkin patch. So here's a rectangular pumpkin patch in the northeast corner of a square plot of land. We can see this is a square because both those sides are x. So it looks like all 4 sides would be congruent. And it does look like right angles. We don't know that other than they said it's a square. But okay, so it says the pumpkin patch has an area of 200 square meters. So I'm just going to write that in there so I remember that's the area of that pumpkin patch. Okay, and then what we want is the area of the plot of land. So if we could find x, then, you know, say x was 15, then I do 15 times 15, and I'd have the area of the square. So that's my goal, is to find x, because then I can solve the problem, okay? So what I'm going to do is come up with a way that I can write an equation for the area of the pumpkin patch. I already know that area is 200, but I'm going to try to find an expression for each of these sides. So if you look, if this whole bottom side is x, since this is a square, that means this whole side is going to be x, okay? And then so if you look at this piece here, you could say it's the whole thing minus the left piece, right? If you took the whole thing and subtracted out the left piece, that would leave you with the right piece. So I can say that this part is going to be x minus 40. Okay, and I can use the same kind of strategy if this whole side is x. Well, all the sides of the square are going to be x. And then I can write an expression for this missing piece. If I take the whole thing and subtract out the bottom bit, that's going to leave me with this part, so x minus 30. So now when we look at that rectangle, for the rectangle we can say, if you're thinking about area, it's base times height, right? So I could say x minus 40, the quantity x minus 40, times the quantity x minus 30 is going to equal 200, because I already know the area is 200. But now I can use this to solve for x. Okay, so what I want to do first is simplify the left side. So I want to write this without parentheses, so I'm going to FOIL this. First, outer, inner, last. Okay, so first x times x would be x squared. Outer, the pieces on the outside, x times negative 30 is negative 30x. Inner, the pieces on the inside, negative 40 times x is negative 40x. And last, negative 40 times negative 30. Well, a negative times a negative is positive. Well, 4 times 3 is 12, and there's 2 zeros, so 1200. Okay, and this is all equal to 200. I can still simplify the left side a little bit because I've got those like terms. So I'm going to combine negative 30x and negative 40x into negative 70x. Okay, so I've got it down to this. Now, I'm going to factor this to solve for x, but if you factor the left side right now, that'll get you right back where we started up here, okay? So I don't want to factor it yet because this equation isn't equal to 0. I want it to be equal to 0 so that when I factor it, then I can use the zero product property, okay? So what I'm going to do is subtract 200 from both sides. Now x squared minus 70x, this would be 1,000. 1,200 minus 200 is 1,000. And now it's equal to 0, okay? So now what I'm going to do is solve this for x. So I'm going to factor this, and this is not going to be an easy task because I've got some large numbers. So I'm putting the negative 70 up here and the 1,000 down here. I'm looking for two numbers that add to negative 70 and multiply to 1,000. So if you're thinking about different ways to multiply to get 1,000, there's a whole lot of them because it's a large number, right? So, you know, you could do 1 and 1,000. Now, I'm going to actually need both of these to be negative because, yeah, 1 times 1,000 is 1,000, but it's not going to add up to a negative number. But these two will add up to a negative number, right? So I'm going to need a double negative pair here. So I'm only going to write down double negatives. But that's not even close, right? Those don't add up to negative 70. So let's try another pair. If I did negative 2 and negative 500, those would add up to negative 502. It's a little better than negative 1001, but still not even really close. So I'm going to jump around a little bit, and let's try negative 10 and negative 100. And you know, you can play around with the calculator to find different pairs, right? You could take, you could say, okay, I want to use a negative 10, so you could do some division like that to see, okay, negative 10 and negative 100. All right, so adding those together, that's going to give me negative 110. Still not negative 70, but you can see as these two numbers are getting closer together, we're getting closer to our sum here, okay? So let's keep going. Let's try negative 20. Okay, so if you think, I know 2 goes into 1,000, so that means negative 2 would. So negative 20 is going to go in. Let's see, 1,000 divided by negative 20 comes out to negative 50. And hey, when I add those together, I got myself a winner there. Okay, so that means when this factors, when I factor this, I'm going to work over here, it's going to be x minus 20 times x minus 50 is going to equal 0. Okay, now since I've got two things multiplied together that equal 0, one of these two products has to equal 0. This is the zero product one of these two factors has to equal 0, the zero product property. It's got to be 0 times something or something times 0. So x minus 20 equals 0 or x minus 50 equals 0. And I can solve both of those. Let's add 20 to both sides here. Okay, let's add 50 to both sides here. And there's the two things that x could equal. Okay, so I got two possible solutions here. All right. So when you have two possible values of x, a lot of times one of them is extraneous, which means it wouldn't work with the original problem. So let's kind of just brainstorm through these. Let's say that x is 20. Well, I could put 20 times 20 as those sides. That's fine. And you can multiply them together to get the area here. But if you put the 20s in here, then we've got a problem because 20 minus 40 is negative, right? And so is 20 minus 30. And you can't have a negative side length. All right, if we put in the 50 in those two slots, we still get positive numbers for the sides of the rectangle. So that means this is the one that I want to use. So I'm just going to throw out the 20, okay? So now let's remember what we're trying to do. We're trying to find, it says, what is the area of the square plot? So let's think about that. Our square, the area is going to be x times x, right? And I'm going to use 50 as x. So 50 times 50, and that's going to equal 2,500. And we were working in square meters here, so we need the units for any word problem. So that is the area of the square. So that one's a rough one, but there it is. Okay. All right, that's the end of the section, and I'll see you next time.